Hello and welcome to Sean White's Solar and Energy Storage Podcast at We are recording live from the Power Up Live Pro Studio presented by Terra Hive. Thanks to RE Plus and Suncast Media for hosting us for this live recorded podcast. I guess live can be recorded, right, Blair Reynolds?
Yes, sir. Thank God for those sponsors. And, you know, in addition to the sponsors, I want to just give a shout out to the sun because, you know, without the sun, none of us would be possible. So,
Man, come on, man. The sun is way overrated, isn't it? Here at this solar conference, all we talk about is the sun. I'm all into LEDs, you know.
Hell yeah.
Tanning machines and stuff like that, or spray-on tans, whatever works. So, yeah, you know what? I was going to pull out my driver's license and prove it to you that my middle name is Blair.
Hell yeah.
It is. You're just going to have to believe me there. And it comes from a long line of Blairs. My grandma took me to this Blair Society.
Yeah?
And there was like the guy that was in charge of it. His name was William Blair, and they called him the Big Blair.
Yes.
And have you ever been to any of these meetings? We must be distantly related, I think.
How do I get connected to the Blair Illuminati? It sounds amazing.
Yeah. So you have to just be on a podcast with me because I'm a part of it, you know, and it's really secret. So don't tell anybody, you know.
Well, tell you what, I'll tell you something you probably don't know. This Blair is a graduate, or an alumni, I should say, of the Sean White Solar School.
All right.
Yeah, man. I took one of your NABCEP prep classes like back in 2008 up in Sebastopol, I think is where we were.
Oh, in Sebastopol.
Yeah.
Was it like, I'm trying to even remember, 2008. It's like, was it the Solar Living Institute up there?
Something like that, yeah.
That was up a little bit further than Sebastopol, I guess. Like, I did go to high school near Sebastopol in Santa Rosa, one of my 3 high schools. But the Solar Living Institute was a super cool place. And they unfortunately closed it down. They had these, like, I called it the revenge of the drive-through redwood tree. And they had these cars, these old cars that they had trees growing through.
I've seen that, yeah.
And I heard that they just cut those trees down, unfortunately.
Oh, no. Well,
and so I'm making a solar training center, and I have a tree already picked out, and I'm going to try to put a car around it.
That'd be cool, man.
Just because I thought that was cool. I hope it's not too copycat, but you know, as a tribute, to the Solar Living Institute, which was just like a very cool place.
Well, I got to thank you because I got through the NABCEP, and that was like, you know, still probably early days of NABCEP. I think it was one of the first 1,000 people to get certified. And I think, as you pointed out, those were some of the John Wiles questions that were on the test in those days, man. And it was a lift. For sure. Yeah,
John Wiles is still on the NABCEP exam committee. I was just talking to Emily Huang yesterday, and she's on the committee with him. So I confirmed it, you know, just yesterday here at RE Plus. And I was on that committee with John too, which was kind of interesting. He's a super smart guy, and he was like the solar code guru of back in those days.
Oh, yeah.
And I can remember, you know, like we'd go around and make all these questions, and whatever he said, he's like, if he said that was a stupid question, you just had to take it as a stupid question.
Sir John Wiles, yes.
Yep. And then it was kind of interesting, too, that we were in class. Bill Brooks and I were teaching a class on Monday here at RE Plus, and we asked the class how many people knew John Wiles, and it's kind of surprising that not everybody knows him.
Yeah.
So
he's had such an impact, and his fingerprints everywhere around here, really, truly.
Yeah. So that was pretty cool. You know, it was like, I was just looking at your LinkedIn. I was kind of spying on you through LinkedIn and stalking you, all that kind of stuff.
All right.
And one of the things that I noticed is that you went to University of New South Wales, and not only did you study, I don't know, it sounded something that could have been solar-like, you studied marsupials.
All right, so let me explain. First of all, I do not take myself too seriously on the social media platform.
It must be genetic because we have that Blair going on.
Yeah, it must be.
Is Blair also like a last name in your family that goes
back?
back?
Yeah, it was my grandmother's last name. Yeah, exactly.
Okay,
yeah,
cool.
So it was a tribute to her.
So we probably really are related. Like, yeah.
Probably.
Yeah.
Yeah, I graduated from the University of New South Wales in Sydney, Australia, with a postgraduate degree in photovoltaics engineering.
Oh, so you definitely studied under Martin Green.
Well, yeah. So, going back in time, like my solar journey, I was at an SPI in 2006 on a whim. A buddy of mine just called me up and said, "Hey, you want to do a road trip?" And, I was sort of like early in my career, kind of trying to find my place in the world. And I said, you know what, that actually sounds like a pretty cool opportunity. So I just, on a whim, showed up in San Jose in 2006. And Martin Green was the keynote speaker that year. And my first exposure to the industry was walking into a room and hearing Martin give a presentation. And I was like, this guy knows what he's talking about. This is fantastic. And then I caught the bug. And so, yeah, it was later on, a couple of years, the opportunity presented itself to go and study there at the university and learn basically how to design high efficiency silicon solar cells, design and manufacture. And man, it was such an incredible experience, hardcore quantum mechanics, but also you get to play around with acid and crystals.
Oh, acid? I think a lot of people did that in college. They're called deadheads.
Yeah, man. But I joke around that I also had a minor in marsupials just because the exposure to living in down under.
Oh, so you really didn't?
I'm just teasing.
You're just funny. But
oh, yeah.
There's a lot of room for funny in this podcast and in this world. Okay, all right. Did you date any marsupials? It's kind of, they have like an extra pouch, to cuddle with?
No, man. But I was fortunate enough. I mean, I saw a bunch of them in the wild, platypus, of course, just like really, really cool stuff, and what an amazing country. It's still very, very close to my heart and very fond of the people down under.
So maybe we should even talk about some of these famous University of New South Wales people. And I've told people in my classes too, like if you really want to learn about like from the best of the best in solar cells, you go to the University of New South Wales, and that's where Sydney is Australia, that part of Australia. And Martin Green is just like you were talking about John Wiles being a guru. Well, he's the world guru, not for the stuff that a lot of times I'm teaching about is like how to electrically hook up stuff, but how to make that magic crystal. So you kind of know magic. Do they really take you back in there and put on the wizard hat? Is that?
Yeah. You know what's cool? You really are inventing the future when you're there studying and learning from these people, because you have to remember, Martin Green is famous for setting the world record for single junction crystalline cell efficiency at 25% back in 1995, right? He designed a cell architecture called the Pearl, passivated emitter rear local contact cell architecture. And it was such a highly sophisticated cell that no one really could actually commercialize it, at least do that and make money. But for so many years, it was still the world record for efficiency. It wasn't until like 2011 that SunPower actually beat that world record. And so It's definitely, he was the inventor of PERC. He did a lot of the copper metallization and things like this. And, plenty of other people, I think as you mentioned, came out of that university, including some of the founders of SunTech, right? And so Dr. Shi.
Yeah, that's who you're sort of working with, I guess, because you're at Bela Solar.
Yeah, exactly.
And Dr. Shi was like, I think he was like on the front of all the magazines for a while. Was he like the richest guy in China or something like that?
Well, I'm not going to make any statements about his personal wealth, but he was nicknamed the Sun King.
Yeah.
And for good reason, because he really deserves a lot of the credit for pioneering the vertically integrated supply chain in China and scaling it just at the right time where, say what you will about the geopolitical situation, but at the end of the day, a drastic decarbonization in our planet as a result of Dr. Shi's efforts and his vision and foresight to go and build gigafactories at a time where, 100 megawatt line was massive, right? Mm-hmm. And just to go all in with local investment and start building a type of module that you could just scale and scale and scale. And so he did. He took the technology from the University of New South Wales, commercialized it and scaled it, and then built a whole ecosystem around him of a supply chain to feed that industry. And then look where we are today, right? Mm-hmm. Again, super important pioneer in our industry and deserves a lot of credit.
Yeah, and I went and visited the SunTech factory probably like 2010 or something like that, and it was the world's largest, most producing, highest capacity solar factory in the world at the time. They had a megawatt of BIPV on the front of it. It was super cool. I went around and I got to tour it, and I still have pictures that I use from that tour that I took there. And I ended up meeting Dr. Shi sometime later, maybe a few years ago, with Madam Mi, who runs SNEC. And so is he here? Do you know? Is he
Yeah,
here?
he's here along with his son, his son, as you mentioned, is the CEO of Bela Solar. So, solar manufacturer based in the U.S.
Great.
Creating jobs in the Midwest and downtown Indianapolis, where we're operating currently a 350 megawatt line making bifacial glass PV modules with domestic content solar cells.
Great.
Right?
Awesome.
And so bringing this supply chain concept that, that Dr. Xi helped pioneer in China, bringing it back over stateside because of the incentives that we have here to do so. Yeah.
Yeah, and I got to tour that factory also over in Indiana, so that was pretty neat. And Bela Solar is doing not just like regular normal modules.
Yeah.
They have this really cool lightweight module that doesn't have frames, that's flexible.
Yeah. Exactly. So at the core of the company, we're really a material science company. The formula for making a solar module is pretty easy, pretty generic. But Dr. Xi, after he left Suntech, he decided to go and try to pioneer a new way to encapsulate solar cells that didn't rely on a very carbon-intensive process in the glass supply chain. So we are the only solar manufacturer in North America that has engineered the glass out of our manufacturing process. And as you may know, there is no glass domestic supply for silicon-based solar cells that exists here in the US today. So we're quite unique in the sense that we don't have to import that glass in order to make these types of composite polymer laminates that we make. So it's a technology that we found in the aerospace industry that we've adapted. And when you think about it...
Did you rip it off from the space shuttle or something?
No, more like an airplane window.
Okay.
So when you think about an airplane window, it's a glass substitute, but it has a lot of the same properties that you would want in an outer encapsulant for solar cells. It's very lightweight, great light transmittance, and great UV resistance. And so we adapted that type of material and made a very durable substitute for glass that is designed to, 25, 30-year life in the field. So it's not your typical flexible module that's for camping or, patio solar, these kinds of things. It really is designed to compete in the CNI space with a highly bankable and reliable technology.
Cool. That's pretty awesome. Yeah, and I guess with these lightweight, what do you call the main part of that module? It's some kind of...
Well, the laminate, yeah.
The laminate.
Yeah.
And that's the main part of the module that's flexible and all that kind of stuff.
Yeah.
And then how does it work too with the cells being flexible? Because cells aren't really usually that flexible. I guess the thinner you cut them, the more flexible and better they are.
Well, yeah. The half-cut cell obviously makes a difference, but it is, as you said, it's crystalline silicon, which is a brittle type of solar cell. And so, I don't describe the product as being flexible. I think that implies too much. I describe it as being semi-flexible.
Okay.
And by that, we will tolerate a 30-degree bend radius.
That's kind of a lot.
Yeah, it is.
Yeah.
But when you think over the full size, the length of the module, which is 89 inches tall, it ends up being a fairly gradual curve. And, that gives us the ability to adhere the module to, curvature surfaces. We put it on things like vehicles. So for long-haul trucking, or as a way that, to power a battery so they don't have to run their diesel at night, things like this. But because it's just such a lightweight module and it's so, easy to install, it just creates a lot of unique applications that beyond just rooftop solar.
So when it's doing that 30-degree bend, is it bending the cell or the areas between the cells?
The areas between the cells, precisely.
Okay.
Yeah, exactly.
All right.
Yeah.
Cool. All right. And then how are you putting that on a roof?
Yeah, so the technology really is quite different in how it gets installed. So we partnered with Dow, who makes a structural silicone-based adhesive that's used typically in building glazing applications. So for hanging glass in skyscrapers, for example. So it's a really tried and true, well understood construction material that stood the test of time. And we've adapted that to use it as a mounting system, basically. So a penetration-free method of adhering a module to a roof. My favorite application for this, Sean, is where you have a corrugated metal roof that just wasn't structurally engineered for the weight of a traditional glass-based solar module. Or think about a value-engineered carport, for example. All these shade structures that we have out here in Vegas for RV parking and these kinds of things. It's a totally untapped market. Our module, with a little bit of adhesive underneath it, bonds directly to that metal surface, the peaks of that metal roof. And it's super fast, easy to install. You don't have to be a roofer, right? You don't have to know how to seal a penetration. You're just slapping it on the roof, man, and plugging in your connectors. So there is no metal exposed. There is no grounding required for these modules. So it's just a totally different process. Now, with that being said, given the current market that we're in today, that's highly incentivizing domestic content product, Most of our production is on a glass 550 watt type of module, and more of a mainstream module, if you will. But the real differentiator is the U.S. content and the U.S. solar cell.
Made in America.
America, man.
So one thing that I heard somebody talk about, and I'm not sure if it was Bela Solar or not, was that if you have like an old solar array and you want to put new PV on it, can you stick it on the front of the old module?
Yeah, I love this application. So my vision is to put it on the old First Solar modules, because it just presents this nice, clean surface where we could bond our module directly on top of the
then you have like
glass.
Multi-junction.
Yeah.
Even though maybe the backside isn't doing anything.
No. Oftentimes these plants are in the process of being decommissioned, but rather than, you might know, just recycling the CAD-PEL in a First Solar is a very cost-intensive process. So why not just use that as a mounting surface and put an additional module directly on top of it? And use your existing mounting system and everything on all the infrastructure that's already there.
And maybe even if you just had a broken module.
Yeah, true.
That needs to be replaced and you're just like, oh man, the other one doesn't fit and it's got to have different kind of clamps and all that.
Yeah.
Just stick one on it.
Yeah, like I said, it creates all kinds of interesting applications that are outside of the normal scope that we think of with rooftop solar. But yeah, it's a cool technology.
Cool. Yeah. We interrupt you for a very important announcement. Shaun White's Solar and Energy Storage Podcast has been brought to you by Shaun White's Solar and Energy Storage Podcast. That's right, Shaun White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And then also you have domestic content with Made in America solar cells, right?
Yeah, Made in America solar cells. We partner with a company in South Carolina called ES Foundry. So they're making a high efficiency mono PERC cell down in South Carolina. And then just this week, we announced our partnership with Origami Solar, making a steel frame here in the U.S. as well.
Oh, I read something about that.
Yeah, okay. Exactly. So we are trying to bring as much domestic content as we can into our products for a lot of reasons, but one of those being the ITC 10% bonus adder and also non-FEOC compliance.
Okay, so steel framed module. What are the benefits and perhaps drawbacks of, because you sell both. So like when would you sell somebody steel? When would you sell them aluminum?
Yeah, so the most obvious benefit is it's just a more rigid material. So you don't get the same kinds of bowing. You get a much higher load rating with a steel-based module frame than you would with aluminum. It also has a much lower carbon intensity, lower carbon footprint compared to aluminum, which of course is great. And it's unique in the sense that you're sort of recreated how you design a frame. It's not an extrusion process, but it's a cold-formed rolling process that they use to form these steel frames. They're made in the U.S., so it's a day shipment away from our factory. They can supply us with a just-in-time business. Some of the drawbacks, though, it is a heavier material, right? So, today we're at the booth, we're showing off a 35 millimeter frame design, but I am moving forward with a 30 millimeter design as well to help reduce some of that weight. Right now, it's about a 5-pound adder to the overall module, but I expect we'll get that down closer to a 2-pound adder.
Great. And so when you were talking about the different types of process, what you were saying, like extruding, so that's like when you're a little kid and you have this thing with Play-Doh and you crank it and it sends out a shape.
Yeah,
that's
right.
The extruding. What did you say?
Formed rolling.
Formed rolling.
It's a highly robotic manufacturing line that they have in Arkansas where they're actually bending these frame profile shapes using heavy machinery.
While it's cold.
Yeah, exactly. Yeah.
And
so it's low carbon manufacturing process.
Okay.
As a result.
Okay. And then with steel, I guess that's pretty good stuff. They make swords out of it and samurai swords and all that kind of stuff.
Yeah.
But there's a lot of different types of steel.
Sure.
And some kind of steel rusts more than other types of steel. There's like stainless steel.
Yeah.
What kind of steel are you using? And then also steel is magnetic too.
Yeah.
So maybe we could have a magnetic racking system.
I love that. Yeah. Well, let's not sleep on it because remember, that's what's going in all of these mounting systems, right? The steel. And we're not seeing those crumbling apart and rusting away in the desert.
Well, yeah, like you have all different types of steel, like your car engine blocks and all that kind of stuff too. Yeah.
So this is a U.S. steel product that they use with a ZMAG coating that goes on it. And that coating is pretty special. It is a self-healing coating. So if there is ever a scratch or something like this on the frame, it actually anneals itself and will, over time, cover that scratch up in the frame to prevent these corrosion from happening. So it's a pretty advanced material, quite honestly. And I'm really, really excited that the Origami announced an acquisition earlier this week from Nextracker. And this is going to open up all kinds of new opportunities in how you rethink about mounting solar and optimizing the frame for the tracker-based mounting system.
So Origami, they make these steel frames, and they just got bought by Nextracker?
That is correct.
And Nextracker is probably doing like the #1 racking company for solar in the United States.
Single-axis tracking, yeah.
Yeah, because most solar in the United States, most solar in the world is on single-axis trackers and utility-scale projects.
That's right.
Which a lot of people don't know because they think solar is all about residential and stuff like that because that's what they see. And so that's kind of a big connection that you guys have now.
Yeah, and it's great to be sort of an early adopter and first market mover with this kind of technology and be already well into the certification process for that module because, again, a lot of opportunity there when you sort of rethink about how to optimize that mounting of the frame for a mounting system in particular. Yeah.
So I always thought Origami was like folding paper or something like that.
It's a bode to the process that they use with the robotics to cold form the frame.
They're doing origami with steel.
Bending bending the steel into these shapes.
Yeah. All right. Okay, cool. Yeah. So you can do origami with steel and you know about magic crystals.
Yes, sir.
And
acid.
and acid, bro. And so speaking of that, I did see Dead & Company at the Sphere here in Las Vegas with my daughter without acid, not how most people see Dead & Company. And I actually saw the Grateful Dead with Jerry Garcia too. Yeah. And so one thing that I saw on your LinkedIn profile was you wrote an article about grid forming inverters.
Yeah.
And I think that's really cool. And maybe we could do a different podcast on that.
Oh, I love that topic. I am a bit ambidextrous. I'm fortunate enough to have worked on not just the module side, but energy storage and power conversion. So I was at SMA for about 5 years. I was their global product manager for their grid forming technologies, which is actually software, believe it or not. But it is a way of controlling the inverter in a way that you are creating the same types of physics that you would with a spinning mass. So that virtual inertia that you would expect in a rotating turbine, for example.
Great.
Yeah, we are emulating that same exact physics with software.
Okay, so I'd love to talk more about grid forming. It's kind of hard to find people that know about it. A lot of times people think, oh, grid forming, that's like an Outback off-grid inverter or something like that. So we're talking about grid connected, and grid forming is really big in Australia.
Yeah, mate.
Because you know how to speak Australian. That's pretty cool, you marsupial. And then let's see, I think there's some other things too that we could talk about, because I remember when SMA and Iron Ridge Solega came out with that first UL3741 system that was kind of controversial. I think you were heavily involved in putting that together.
Well, that was my project.
Yeah, okay.
Oh, man, and that's a story right there in itself.
So maybe we've got 2 more podcasts that we could do. So let's do it, Cousin Blair. And I remember going to that Blair meeting with my grandmother, who's like, that's where my Blair came from, was my grandmother. And she wanted me to go there and meet the big Blair, and William Blair, I think, was one of my relatives.
The Blair Witch was also there.
The Blair Witch. Sometimes people call this podcast Blair Witch-like because I'm not so big on like doing everything perfect as like the other podcasters, because I have, I'm more like get as much out there as I can and stuff like that. Like I don't plan, like we didn't know what we were going to talk about, and that's why it's so good. But that would be great. And I remember there was like a Blair family that came actually from France to the Scottish lowlands, and they made a Blair castle. That's where our genes meet, and then we'll have to look for each other on 23andMe.
Yeah,
I guess that means we can't date, so all right.
Well, you know how to find me on LinkedIn, it sounds like. So yeah.
Right. Okay, Blair,
let's do it.
Yeah, Blair Reynolds, Bela Solar, thanks for joining us on Sean White's Solar and Energy Storage Podcast. We are recording live from the Power Up Live Pro Studio presented by TerraHive. Thanks to RE Plus and Suncast Media for hosting us. And don't forget to go to Solar, SEAN, that's SolarSEAN.com, and get yourself NABCEP certified like Sean Blair White and like Blair Reynolds are NABCEP certified. Right, Blair?
That's true.
Ow!